is display prime numbers between the intervals using a function. So it will allow user to enter the intervals and it will only display the prime numbers within that interval. That is a program we need to write. So basically, let me check why it is not getting full screen. So I guess it is visible to you. So basically, first thing is include stdr.h. This part will include all the standard libraries. Then you define your functions like a predefinition. So you will return int check prime number int comma n. Okay. Now your main loop starts. So int main curly bracket open close. Then int n1 n2 and flag. Four variables defined in the int type. You will ask the user to enter two positive integers, that is n1 where the starting point of all the prime numbers and n2 will be the end point of all the prime numbers. And then you will say print prime numbers between %d and %d are, and then just give a colon space and leave it and display n1 and n2 inside this. Now let's go and see a loop. So for I going from n1 plus 1 to n2 and in steps of 1. So here you will see flag equal to check prime number I. So program for verifying whether it's a prime number or not. That is a flag checking program that we will write as a separate function. Then if flag is 1, just print that number, whatever is the value, and go ahead. So this is how the simple program is. And inside the check prime number function, we pass an integer n. So let's say user has entered 13, so it will pass on 14. And then that value will be assigned to the variable n. Along with that, we also need j and flag equal to 1 by default. And we will see that for j going from 2 to that number by 2, because if it gets divided by half of its numbers, remaining half is automatically there. So that's why for checking a prime number, you should always go up to n by 2 instead of full n. You can go up to full n also, it doesn't make any difference. Your result will remain same, but execution time will be half because you are doing half the computation. Then next line is if n mod j equal to 0, that means it got divided by j. So if n got divided by j, set your flag to 0, otherwise keep it 1, and then you return the flag. So it's a simple program, and basically if you receive flag equal to 1, it will display that prime number. So here is the output. User has entered 12 and ending number as 30, and the output looks like prime numbers between 12 and 30 are 13, 17, 19, 23 and 29. Now if user enters the number larger than the first program, the program will not work as intended, and that's why you have to first compare the two numbers and swap them if the user do not order the number in a sequence. So this is what we call the software testing. The first code we wrote, it's something where what developer does, it just generates the basic first version of the code. But then when user works with that code, you will realize that they are making this kind of mistakes, and with that iterations of the code is generally taken. Typical code development cycle is about 10 iterations per code. So there is 10 types of mistake always a user will do, and that's why along with the software developer, there are roles in a software company, which roles are called software tester. So whatever developer has developed, the tester will try to create as many bugs as possible, and just to avoid the issues, software tester will generate the problems and give it to the software repair team, and finally it will work like that. Next is checking a prime number and Armstrong numbers. So this is a code with respect to functions. We have to write two functions. That is, first is check prime number and also check the number is Armstrong or not. Then user will ask to enter a positive integer, scanf. So we will read that integer, and then we will set flag for prime number. If flag is 1, the number is prime number. If flag is not 1, number is not a prime number. And this is the first time we are also declaring a second function. So till this point, we were only learning declaring a one function at a time. but this time in our code we are declaring two functions at a time, and that's why you will see the scroll bar over here. So flag equal to check Armstrong. Again, you will see that flag is overwritten over here. So make sure that you can use flag one instead of same flag. That will help us in avoiding the overlapping problem. And if flag is one, that number is Armstrong number, else the number is not an Armstrong number. So let's see what is inside the functions. Uh, so first thing is inside this. Inside the check prime number, we will declare two integers. So this code is exactly same, but here instead of n by 2, we are using a function called square root. Okay, so for each number we will compute a square root of it, and if that square root is not modulus till that point, then we'll keep the flag at 0. Otherwise we will return the flag, which is by default set to 1. And for the Armstrong number, what we are doing is we are checking the remainder, and for that original number, remainder, n and flag are set. By default we set the result to be 0 0. Then for original num, going from num, say original number is not equal to 0, we increment the n, which is by default was 0. Now original num by 10. So this is the way we swap the number, and once we do that, again we will calculate the remainder to extract the last bit of the number, and then we get the reverse of the number. That is, result is equal to power remainder comma n, and based on the reverse number it's same as rounded number, then you set flag as 1, else your flag is 0, and this is how you checked your Armstrong number. So here the enter number was 407. So 407 was a prime number but not a Armstrong number. So you can see the flag was set with the prime number, but it got overwritten because of the Armstrong number gave the false result. So this is how the Armstrong number works. Now next code we are going to learn is program to check whether a number can be expressed as a sum of two prime numbers or not. So in this example, we will check if an integer entered by the user can be expressed as sum of two prime numbers of all possible combinations. Okay. So you will ask user to enter a positive integers. In the declaration, we already defined check prime, which is our basic thing. But now what we are trying to do is we will go for 2 to n by 2. If it doesn't happen within the half loop, it will never happen, and it will keep on incrementing I per steps. So check prime I equal to 1, and if prime n minus my equal to 1. So this is how the addition of the two prime numbers are checked, and if it is yes, then you will print that particular value and set the flag to be 1, and if that flag is not 1, then you can say this particular number cannot be expressed as the sum of the two prime numbers, and you will return the value. And again in check prime you have the similar code, n by 2 tak jao, value divide karte hue, and then you save it's a prime number or a not. So this is the code about is prime, and the output will look like here. Enter a positive integer. User has entered 34. So the first prime number 3 and 34 minus 3 was 31. Both were prime numbers, so it got displayed 34 equal to 3 plus 31. Similarly, 34 equal to 5 plus 29, 34 equal to 11 plus 23, and also 34 equal to 17 plus 17. So these are the four possible outputs of this particular program. Now, next is C program to find the sum of natural numbers using recursion. We have already seen this code yesterday, so I will just run through it again. Here, you will declare the function add numbers and pass an integer n to in. Also remember, this particular function will have a return as well as argument. So this is a good way to write a function. So int num printf, enter a positive number %d, and then you will scan that number, and then printf percent add numbers. You will directly pass num and get the return. So there is no variable wastage. It is directly inside the print statement. So you can call your defined user defined function inside another function, which is printf, that is a standard function. So remember, this is what we call a nested function call. So function inside a function. So printf itself was a function. Inside that, we have already called another function. And inside add numbers, you have following things. Int n, if n not equal to 0, then return n plus add number n minus 1, else just return the value n. So depending upon the recursion, for example, enter a positive integer, user has entered 10, 20, and the sum was displayed as 210. So this will keep on happening. It will keep on adding the number to itself till the n becomes 0. So this is another way to get a natural number sum using a recursion method. Why recursion method? Because inside the add numbers, we are calling a add numbers function. So it will keep on subtracting. Okay. So let me just try to explain you this. It is like basically, let's say you have entered 20. So it will do 20 plus all the previous addition of 19. So 19 is passed to the next function, which will do 20 plus. Now this function will do 19 plus all the valid addition till 18. So this is what we call a recursive call, and this recursive call is what we call add num function over here. So add num में से 19 पास करके यहाँ से कॉल किया गया, फिर एड नम को 18 पास करके यहाँ से कॉल किया गया, और ऐसा करते गए हम till it reached to 0. So as soon as it reached to 0, it was not calling add number 0, and that's why we stopped the coding, and that's why you got your final answer as 210. Whereas यहाँ पे क्या होता, इस वाले फंक्शन का आंसर आता 190 प्लस 20 करके 210 हुआ. So this is how the recursive call. So इसको हम recursive बोलते हैं. मतलब मैंने अगर फंक्शन डिफाइन किया है NINAD, उसी में से अगर मैंने कुछ 2-3 लाइन लिखने के बाद वापस NINAD कॉल किया, सो निनाद निनाद को ही कॉल कर रहा है. हाँ, कुछ तो ऐसा फालतू मूवी भी था, कार्तिक कॉलिंग कार्तिक. So basically, recursive function is calling a same function from the its own declaration, and that is where the recursion occurs. Don't forget to give the if loop. If there is no if condition, you will be in a bad situation where you will put your code into an infinite loop and it will hang, and it will keep doing the same thing again and again. I know real-time system always have a recursive call. That is because it is always useful to keep your system developed every time it is running. So initially add number is called from the main, which is not a recursive call, but inside the add numbers, it was a add number 20 was calling to add number 19, and next function call add number 19 will call add number 18, and so on till we reach 0. When n is 0, the recursive call is terminated. There is no further recursive call, and hence the integers are returned with the natural number addition. Next is C program to find the factorial of a number using recursion. So remember, in the exam, if they don't mention write a program to find a factorial is only the problem statement, you don't have to use recursion. If you find recursion is easier than your regular methods, then only you go for that. Otherwise, declaring a flag and waiting for that flag to become a 0 is a good idea to find a factorial or to have an addition of first n natural numbers. And there are many other programs like Fibonacci series, everything, which you can also do using a recursion method. So here is an example of finding a factorial using a recursion. So first I will show you the output. Enter a positive integer, enter a number was 6, and the factorial of 6 was 720. So it is a similar program, exactly same. If you see, the only thing is multiply number instead of add number, and in each multiply number we are passing n minus 1 to the return value. So होता क्या है यहाँ पे, it will keep on doing this and finally it will return everything. So that's why it's a very smartly written code. And today after the lecture, I want you to try this, any of these two, either add number or multiply number using recursion for the C programming. Now, suppose user entered 6. Initially, multiply number is called from the main with the 6 number passed as an argument. Then 5 is passed to the multiply number from the same function, what we call the recursive call. And in each recursive call, the value of argument n is decreased by 1. When n becomes less than 1, there is no further recursive call. And then the finally factorial value is returned. And ultimately, the main function is called. So it is similar to calling if, and as soon as the last if ends, everything starts coming out. That is end. So similarly here, recursive call does the same thing for you. Now next is again write a program to find GCD using recursion. So in the exam, if they specifically mention use recursion, then only you have to write the program and give a recursive call. Otherwise, please avoid recursion because there are chances that you will put your code into the infinite loop and it will keep on running. So here is the example of finding a greatest common divisor of two positive integers entered by the user using recursion. So first we will see the output. Enter the two positive number. User entered 366 and 60, and the GCD of these two numbers is 6. So how do we reach till this point in the programming? We will see now. So include stdio.h. Then you have user defined function HCF, and then which is highest common multiplying factor. Int n1 and n2 are passed to it. Then main loop starts. You ask user to enter two numbers. User will enter two positive numbers. Now, why we are taking only these examples? Because we already know all these examples without recursion. So that's where your logic or algorithm is already known to you. You just have to implement it using a recursive call. So here what you are actually doing is you are taking two numbers from the user and then you are passing n1, n2 and HCF of n1, n2. Okay. So inside the first HCF call, we got two numbers. Now we will say till n2 is not 0, return HC of n2 comma n1 modulo n2. Okay. What will this modulo operation will do? This particular modulo operation will keep on dividing n1 by n2, and whatever is the remainder will be further passed to the HCF from the HCF itself. So it will keep on doing this particular operation till the remainder becomes 0. Finally, whenever n2 becomes 1, then it will stop the operation at that particular point. So it's a very fast converging technique, the modulo. Instead of hundreds of loop, it will immediately reach to 0 because it is not getting divided by any other number. Otherwise, return n1, and based on the value, it will declare. So 6 was the n1 value, where the modulo operation was 0 and both numbers got divided by each other. So it's a very fantastic code, and it is generally asked for 10 marks in the exam. So don't miss out this particular code for recursion, GCD wala. Now next is write a program to reverse a sentence using recursion. So how we will reverse a return statement using recursion, we are going to learn. Here you first write reverse a sentence function which is not returning anything. So remember, this particular function is just called from the program. It has no arguments and nothing returned. So here you will say main, enter a sentence and reverse sentence. Okay, return 0. Now here inside reverse sentence, you will declare char C. You will scan the C that user is typing, and since C is not equal to /n, you will keep on calling reverse sentence function. As soon as it is hitting that particular point, it will display the sentence. So sentence was Margot emboss. This is what user has entered, and at the end of the day, it got translated to awesome program by the reversal of the statement. I know it is very difficult to read this one, but it is very easy, straightforward to read this one. So now we haven't learned anything about arrays yet, but still you can reverse the statement directly using a recursive. There is another way called arrays to do this same program that I will talk to later. So After this lecture, you will still write this program also, that is reversing the sentence. So this program first prints the enter sentence and then directly calls the reverse sentence function. Inside the function, it will store the letter C, and if there is no slash n, it will keep on calling reverse sentence again and again. So here the memory occupied goes on increasing, and this process continues until user hits the enter. So as soon as user hits the enter, the actually slash n command is given to the uh, computer, and then it will understand that now he can print the reverse function statement character from the last C. Next is write a program to calculate power using recursion. So power is one of the easiest program that one can write using recursion. What you have to do is stdio.h. You have to declare power. There are two integers n1 and n2. So 2 raised to 8, yeah, 8 raised to 2, whatever you want to do, that is achieved using a power recursive function. Now int base a and result are the past number, so it will ask user to enter a base number, then enter a positive power number which is a positive integer, and you will ask to scan. So now you have to think what will happen if user enters half or something like that, because you have already declared int. So this will only generate a power for the positive integers. You can enter 1.5, but it will automatically truncate it to 1. And finally, result power, you pass base and a to these functions. Then printf, you will say a raised to b is equal to something. So this particular symbol is for raised to. So what we call Kaveka pair. So this particular symbol is for the raised to, and then we return 0. Inside the power function, it takes the two variable, and till a is not 0, we'll keep on taking the power, that is a into, so how you take a power, multiply 2 raised to 3 is 2 into 2 into 2. So this is what this particular operation is doing. It is passing the base, and a minus 1 is getting subtracted every time. So base into base is what the operation is happening, and as soon as it ends, it will return the 1, because there is the power raised to 0 was called by the user. So here is the example, user enters 3 and 4, and then 3 raised to 4 is 81. Next is C program to convert a binary number into a decimal number and vice versa. So those who are not familiar with the binary and decimal numbers, I will just explain very shortly what is a binary number and what is a decimal number. So here just try to focus on this. You want to find out binary for 7. Okay. So what you will do is you will first divide 7 by 2. Okay. The answer will be basically 3.5, but you don't have to consider that. You have to consider 3 with remainder of 1. Okay. Now next is you have to divide 3 by 2. So the answer should be 1.5, but again you will consider answer, it is 1 and then remainder of 1. Okay, and finally that 1. So 7 binary is 111. Okay, so this is how it is written. You write 7. Okay, when you divide it by 2, it will be having 3 and remainder is 1. Again you divide it by 2, the answer is 1 and remainder is 1, and then you write in a reverse order. So this is your final answer, 111. Now let us try to do for 15. Okay, again 15 you divide it by 2, the answer is 7 and remainder 1. Okay, then you divide it by 2, the answer is 3, remainder 1. Then you divide it by 2, answer is 1, remainder 1, and the correct answer for 15 is 1111. Now let us try to do something for 12. So 12 is completely divisible by 2. So what will happen? If you divide 12 by 2, the answer is 6. The result remainder is 0. 6 is completely divisible by 2. So answer is 3. The result of remainder is 0. Then 3 is further divided by 2. So answer is 1. Remainder is 1. So the final answer for 12's binary is 1100. How I got that? If you write in a reverse way. Okay. Similarly, I want all of you to try out right now 27 with me. Okay. This is a bigger number, but we can do it. So 27 when divided by 2, I guess 13 to the 26, and then remainder of 1. Then 13 when divided by 2, 6 to the 12, and remainder is 1. Okay. Then next is 6 will result into 3 with remainder of 0. Then finally 3 will have remainder of 1 and 1. So final answer for 27 in binary is, if you do a reverse calculation, it is 1 1 0 1 1. Okay. So this is how the binary to decimal conversion is done, and how to do a vice versa operation. So you start with the first integer. This is 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2. Okay. And then finally 2 raised to 3. Okay. You keep on adding, and particularly whatever is the multiplying factor, you multiply with that. So let's say 1100. I will start a fresh page. So let's try 27 first. 11011, and I want to find its binary. So please focus on this one. If I ask you to convert 11011 as a decimal number, what you will do is, first you will write 2 to the power below each number. It will always start with 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 4. Okay. Now those who are good with mathematics can easily figure out this. 2, 4, 8, 16. Okay. And now wherever there is 1, you have to keep that number. So 1, then there is 1, then wherever there is 0, you just discard that number. Okay. And then again 1, you keep that number. So this particular number just multiply. So this will be 16 plus 8 into 1 will be 8 plus 0 into 4 will be 0 plus 2 into 1 will be 2 plus 1 into 1 will be 1. And if you do the addition correctly, answer should be 27, because we already know 27 binary is 11011. So this is how the reverse operation is done. Now I want you to try out with me. If my binary number is 1011, what will be the correct answer for it? Okay. So this particular is 1248. Okay. Now I am not writing this 2 raised to panda. And now if you do the correct addition, 8 plus 2, 10 plus 1, 11. Okay. So this is the correct answer. So fantastic. So let's try to understand how to convert a binary number to a decimal and vice versa using the recursive operation. So this is a program for it. Now, what the operation I was doing, power of 2 raised to I. Okay. POW is a function directly available with math, which we just learn also how to get the power. But here it is directly using a POW function. So the program starts with include mat.h, include stdio.h, two inclusions. Then integer convert long n. Okay. So we are passing a n through a convert function. Then int main user define long n. Now here you whether to define long or whether to define double, whether to define only float or only int, the choice is up to you. But preferably long is used when you have maximum memory capacity. Okay. So printf, you will ask user to enter a binary number, then you will scan %lld because it was long integer, and then ampersand n. Okay. Then you will also display %lld in binary is equal to %d in decimal, and then you pass n, which was the user entered number, and convert n, which is the function that you wrote, and return 0. Now inside convert, you read this particular n. You also declare dc equal to 0, I equal to 0, and remainder. So whatever operation we are doing now, it is done automatically using a program. So while n is not equal to 0, to keep on multiplying, rem is equal to n%d, and then this is basically similar to what we did earlier. You get it divided by 10. Okay. And then n is equal to that particular number equal to number by 10. So let's say your entered n is 110. Okay, so basically you knock out the remainder. So that is how you convert your binary number into a decimal. Uh, so let's say user has entered 110. So when you divide 110 by 10, what will happen is this last zero will cut off and knocked off zero will be displayed over here, correct? Then again, when you do 110 divided by 10, so it is now 11 by 10. So this last one will be knocked off as a remainder, and 11 will become only 1. And finally, again, there is no need to divide 1 by 10. Okay. So this is how you are knocking off the last digits as a remainder. So user can enter 1101111. Okay. Now when you divide it by 10, this particular remainder will come off, and rest of the number will remain as it is. Okay. And this is how you are using long instead of double. So that's why the choice was integer type. And why long? There is no reason. You could have just used integer also. Next is, now you want to finally calculate the decimal value. So whatever is the remainder knocked off, you multiply it with the power of 2 raised to I. This I is automatically incrementing with each loop starting with 0. So 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2. And then finally decimal is returned. So it is very difficult to understand the program. And I want you to start with this particular code as soon as we finish the recording of the lecture to convert a binary to decimal. Now, reverse way is decimal to binary. So instead of multiplying by 2 to the power something, we have to divide by modulo 2 operation to get the remainder and the quotient. Okay. So for this particular code, again, you will require math.h and stdio.h, two library files. You also need user defined function called convert. Then first line is declare your main function, then declare your integer n. You will ask user to enter a print decimal number, and finally you do a scanf of %d slash n. Now here you will ask you %d user entered number is %lld in binary, and you pass this n as a convert function and return 0. So this is your main program. Now inside the convert function, you declare a binary which is starting with 0. Okay. Now here you declare another integers called remainder I equal to 1 and step equal to 1. Okay. Now while n becomes not equal to 0, you keep on doing this. First thing is, whatever is the remainder, you divide it by 2. So those who remember what operation we did for, let's say, 11. So 11 by 2. The answer is 5, remainder is 1. Correct? So this particular n percentage 2 is actually using this by 2. And then whatever is the answer, you are just dividing by 2. And remainder is been multiplied with the I. Okay. So I is every time multiplied with 10. So actually, though you are seeing 110 in binary, the actual number in the sequence is 110 in decimal for the program. Okay. So if you try to do the binary operation on this, it is not actually a binary, but you are actually displaying 110. Remember this. But you, for the user, he will be very happy because he will see all the output in terms of ones and zeros, and that's why the name binary is there. Binary means 2, or it has only 2 levels, either 0 or 1. Okay. So here is one example, decimal. So 19 was entered. So it has a remainder of 1 and quotient of 9. Then again 9 was divided by 2, so it was remainder of 1 and quotient of 4. And then 4 was divided by 2 with the remainder 0, quotient 2. Then 2 was divided with 2, so remainder 1, quotient 0. And finally 1 divided by 2 half, which is remainder 1, quotient 0. So this particular action will exit the loop, and your final answer will have answer as 10011. So 19 is in decimal 10011. Okay. Now next is, similarly you have to convert an octal number into a decimal and vice versa. So simple way to octal to decimal I will just teach you in short. This entire separate subject is there on this number system, what we call digital logic into your semester 3, but I am just teaching you how to do it in short. If I ask you to convert a octal number 9, okay, so decimal number was 9 and in octal it will be 10, okay. So नंबर सिस्टम अगर आप देखोगे तो डेसिमल जो होता है वो जाता है 0 1 2 3 4 5 6 7 8 9 10 11 and so on, okay. This is how your, so basically यहाँ पे हो क्या रहा है, 9 तक ही जाता है डेसिमल सिस्टम और उसके बाद 10 लिख देते हैं हम, okay. Then 10 11, so 11 actually means basically it is 10 plus 1, okay. Then you have 12 which is 10 plus 2, so 10 plus 0 10 plus 1 10 plus 2 and so on. So basically you have shifted this one position, then it becomes 2, then it becomes 3 and so on. In octal number system this is totally different. It will start with 0 1 2 3 4 5 6 7, okay. Unlike your binary which will go only between 0 and 1, octal can go up to 7, but octal will never have 8. So I guess I have made mistake over here. So in octal system 8 is never displayed, you will have 1 0, okay. 9 will be 1 1 and 10 will be 1 2. So it's very confusing if you try to convert your octal to binary directly, but whatever operation we were doing with the answer. So if you see 9, when you divide it by 8, the answer is 1 and remainder is 1, and that's why the answer 1 1 is correct for the 9. Let's say if you want to find 15 in octal, so if you divide 15 by 8, the correct division will result in 1 with the remainder of 7. So 17 in octal. Remember this. So 15 in decimal, 17 in octal. Similarly, if you want to find what is the value 256, okay, it's a big number. So 256 in decimal, what is will be its value in octal? Remember the one thing that it will be always greater than 256. So number in octal system is always greater than number in decimal system. और उसका पहला ही example, when you divide 256 by 8, the first 25, 8 threes are 24, so it will be 300 something something, correct? So only remainder is 1 with this particular division and then 20. So similarly, you will have 300 something something into your octal system, and that will find through your C program. So this is the program to convert octal to decimal and vice versa. So you'll see the code is exactly the same as binary to decimal. Only change is here you have to divide by 8 and then multiply with the power of 8. So that is the only difference between the two codes. So octal in 78, in decimal, in octal you will get 116. Similarly, octal to decimal, instead of power of 2 raised to I, you have 8 raised to I. Otherwise, the entire program is exactly the same. Yeah, this is the complete code for it. And the octal number 116 is displayed as 78 in decimal. Next is binary to octal and vice versa. So there are mathematical ways to do it, but a simpler way, if I give you binary number 1101111011101, it's a very big number, and it will be very difficult for human to convert it into octal. And binary to octal typically has this lookup table, but today we are not going to learn about those. So lookup table means 0 0 0 is 0. So last digit 0 1 0 1 0 1 swap करते रहो, ठीक है. फिर ये digit 0 0 1 1 0 0 1 1 swap करते रहो, and finally 4 zeros और 4 1 ऐसे आप swap करोगे तो आपको एक lookup table मिलेगा. ये lookup table ये कहता है कि ये होगा 1, ये होगा 2, ये होगा 3, ये होगा 4, and similarly up to 7. Now 101 is basically 4 plus 2 plus 1, पर 2 का multiplying factor 0 है, so this is 5. Then 101 again, so this is 5. Then 111 again, so this will be 7. 101 5, and finally 1. So this is your final answer in octal. So binary to octal is very easy. आपको जो भी बाइनरी नंबर है उसको ग्रुप ऑफ 3 में डिवाइड करना है और उस 3 का जो भी अल्टरनेटिव वैल्यू है उसको प्लेस कर दो. But this is a trick that is without programming you can apply to convert a binary number into a octal number. So here is the actual program. So what we are doing is you are actually converting it into a decimal and then write a code for decimal to octal. So this first part of the code is converting a number into a decimal by multiplying it with power of 2, and then there is another function that uses divide by 8 operation to convert decimal to octal system. A computer can easily do it, but with human also you can see. If you see this particular example, it is 101001. Okay, so this particular lookup table says this is 1, this is 5. So these are the answers. There are some tricks by which you can compute faster than your computer, and it is possible in multiple cases where human can still compute faster than any computer, because that particular logic was not implemented into the computer, and that's why human can do a faster things. Similarly, for vice versa, the program changes. So first we'll convert a octal number into a decimal number, and finally decimal to binary. So this is how the particular program is working. Uh, so if user enters 67, the answer is given as 110111. Again, if you ask me what is the let's say octal to binary of 167, I can easily write it. The 1 means 001, 6 means 110, and 7 means 111. So you will say that it's very fast, but yeah, you have to remember the simple lookup table for this. So you can ask your computer to do the same thing. 167 का answer यही आएगा. You can check it. And with that, we will stop recording now, and we'll continue with our actual programming. So if you have any doubts, you can ask me.